How to complete a high school Euclidean proof. Euclidean geometry is one of the first mathematical fields where results require proofs rather than calculations. Proof writing is the standard way mathematicians communicate what results are true and why. The entire field is built from Euclid's 5 postulates. Method 1 Preparation. 1. Read the statement of the problem. Understand the definitions of all terms in both the givens and the proposed conclusion. 2. Draw a diagram of the situation. Make all angles and distances as accurate and to scale as possible. Label all relevant points, angles, and distances. Note how each of the given assumptions manifest on the diagram. 3. Redraw the diagram. Your first version will probably be unsuitable in some way. Maybe it was too cluttered to read clearly, maybe the intersection of an important pair of lines is off the page, maybe you were told to assume that 3 angle bisectors of a quadrilateral intersected in a single point, and that doesn't happen with the one you drew. In any case, you learned something from the first attempt that will make your next attempt better. 4. Make observations from the diagram. Do 2 lengths look equal? If so, can you prove it? What plausible hypotheses, if true, would help you derive the intended conclusion? Write down any relationships between various parts of the diagram that you can derive from your assumptions. Note, this is where an accurate diagram helps. If 2 angles look unequal, then you know that no correct proof will involve the assertion that they are equal. With an inaccurate diagram, you never know. 5. Recall or look up any previous results that might help. It's very common for mathematical results to depend on previous work. Hint: if a theorem has a name, like the Pythagorean theorem, or an abbreviation, CPCTC, for corresponding parts of congruent triangles are congruent, it's probably used frequently in later results, so make sure you understand it. 6. Work backwards too. Try to guess the second to last line of the proof. If you're trying to show that the areas of 2 triangles are equal, what would you need? Maybe they're congruent, but that's a much stronger result. If an edge of one is congruent to an edge of the other, then can you show that the corresponding altitudes also have the same length? 7. When you've discovered a way to logically link the initial conditions with the conclusion, make a proof sketch. Highlight the important intermediate steps and the major theorems needed to derive them. Method 2 Formal proof. 1. Draw a diagram. This doesn't have to be overly accurate. Formally, it isn't required at all, but it usually helps. Name all points, angles, or other features that you intend to refer to in the proof later. 2. State the theorem. State the given assumptions, and what you intend to conclude from them. 3. Set up the format for a 2-column proof. Label the left column statement and the right column reason. 4. Repeat each of the givens for the first few rows of the proof. For the reason, write given. Even if some of the givens aren't needed until later, it can't hurt to list them early. 5. Aim towards the first important intermediate result you found in the preparation stage. Write each step towards that result, and justify each with an appropriate reason. The types of acceptable reasons are small. They include given, definition, axiom or postulate, previously proven theorem or lemma, formula, law, etc. 6. If the reason is a theorem, be sure to specify which one and why it applies. The following methods are usually acceptable. Restating it. The three altitudes of a triangle intersect in a single point. Referring to it by name. Thales theorem. Reference to a text. Theorem 5.3 on page 124. By a standard abbreviation. SAS. 7. If a theorem has conditions attached to it, you should explicitly show how they are satisfied. For example, if your statement is that triangle ABC is congruent to triangle DEF, you might use this detailed reason: BC equals EF, line 5, and LT, ABC equals and LT, DEF, line equals 13, and LT, BCA equals and LT, EFD, line 16, and the ASA congruence theorem. Where the earlier 5th, 13th, and 16th lines of the proof show prerequisite angle and side congruences for ASA to apply. 8. Continue working towards your conclusion by establishing the other key intermediate steps you found in the prep work. Make sure that each step follows from the previous ones. 9. The last line of the proof should be the desired conclusion. As with all other steps, justify it with an appropriate reason. 10. Optionally, terminate the proof with QED, a box, or some other similar mark. Warnings. Be alert for any hidden assumptions. There is a famous fake proof, sometimes attributed to Lewis Carroll, that all triangles are isosceles. The error is subtle when presented like this. All triangles alleged to be congruent are, indeed, congruent, and for the reasons stated. There is a hidden assumption implied by a misleading diagram in which a point C is drawn on the line segment AB is used to justify AC plus CB equals AB. An accurate diagram will reveal that C is not between A and B and lies on the extension of that line segment, showing why the proof goes bad. In introductory geometry courses, it's common to require the use of two-column or similar proof formats where each step is formally justified. In more advanced work, this is less common as excessive rigor can distract from the important ideas. Still, it is expected that an informal paragraph proof could, upon demand, be converted into a fully rigorous proof with an explicit justification for each step. If a problem statement is accompanied by a diagram, you may, usually, assume that the diagram is not intentionally misleading or self-contradictory, but do not assume that it is drawn to scale. Verify any aspects of the diagram that you may need to rely on.